marbles. You think I've lost them. You're right, but now you can lose them too. About a year ago, I built a giant clock that tells the time using marbles. And I think it's time for you to try and lose your marbles, to lose the will to. And I think it's time for you to have fun and build one too. But that's not as straightforward as it seems. Straightforward? Let me explain. When I built the original clock, I used a 13 by 31 matrix, which makes for huge numbers and a very nice way to display the time, but also makes the parts required to build the clock huge. And that's a great excuse to not build a clock, because who has a printer this big? But if we reduce the display size to 5 by 17, everything is way smaller. So every single part of the entire clock can be printed on any printer that has a print bed of just 200 by 200 millimeters. See, you have no excuse now. You are doomed. Of course, this took a complete redesign of the clock, but right now I'm way more experienced domesticating marbles, so this build should be way easier. So let me show you how you can lose your own marbles in the comfort of your own home. Let's start with the marble display section. This one is built joining all these channel sections with these brackets and lots of screws. And to know which section goes where, I use some fancy multicolor printing to print the numbers in white, but don't worry, because those can be also seen in single color prints. I thought of everything. Good start, but marbles still go to the floor, so we need to add now this tray section that will collect all the marbles that fall from the channels. The bottom tray is also made joining a few sections that are joined again with more brackets and more screws. And with this transition part in here, we can join the channels to the tray with another bracket. And this is now the complete circuit. And marbles are collected at the bottom tray. But this doesn't stand by itself, and although in the large version I used an aluminum frame to hold everything, I think this is small enough so I can get away with a 3D printed one. So I made this. I made it joining these two parts for the base, these brackets in here for the bottom roller, this large section in here that will hold the solenoids and all the electronics and sensors, and these two in here for the top roller. And this fancy part in here to support the channels that are just hanging over here. And that's it. This should be good for a frame. I just need to add this bracket in here. And we can now attach the channels to the frame with 2 screws in the front, another one here, 3 more in the back, 4 more down here, and these 4 in here for the extra support. And it stands by itself, and the marbles go all the way from the top to the tray, and now we need to do the opposite trip from the tray to the top. And for that we need an elevator. So I printed this whole bunch of elevator links that we need to assemble. It may have seen that I was driving the screws very carefully at the end, so I don't fasten the links together and they don't rotate. But there is a design feature on the links that eliminates that issue altogether. I made the holes on each link short enough that even if you go all the way to the end, the screw cannot go deep enough as to screw two links together. To move the elevator links, I made this driving wheel in here, joining these three parts with, again, lots of screws. And added one skate bearing on its side, and we can set it up here with one 8mm rod that is kept in place using a screw on its side. For the drive system, I went with a helical gear design, and now we need the small gear for the motor. And trying to make it last as long as possible, I printed it in carbon fiber PETG. But not everybody has access to fancy materials or can invest on a new machine just for a one-off. And that's where today's video sponsor, PCBWay, comes in handy. Let's say that you want to have this helical gear made out of metal. You just have to go to PCBWay.com, add the design you want manufactured, check the design in the online viewer, set the amount, and choose the right material for your application. In this case, I chose stainless steel, but you can choose from a wide range of materials from regular PLA all the way to nylon or titanium. And the best thing is that you get your parts back in no time. Look at this. And PCBWay not only does provide 3D printing services, they also offer CNC machining, injection molding, sheet metal fabrication, and a lot more. As you can see, the process is super easy and the quality is top-notch. I mean, that's stainless steel. So give PCBWay a try following the link in the description. And now let's keep rolling. And I mean it because we need to add another roller at the bottom, and this one is assembled exactly like the one at the top. With another M8 shaft. And this one will do the tensioning, that's why it slides up and down, but more on that later. And we are ready to install the elevator. It seems that I made a few too many links. On these bottom brackets, there is a hole on each side for these screws that will act as tensioners. This doesn't have to be too tight, it's just to prevent the elevator from flapping around. The marbles go up, but I forgot to install the marble rejection mechanism in here, so I will remove one of many times the elevator links and install it now. I should have done this before installing the top roller. It would have been way easier to fasten these screws from the top. Much better and louder, much louder. It's always the same. The goal when I made the redesign of the clock was to fit everything inside the column, but this thing has almost the same amount of stuff as the large clock, so I had to play some Tetris and everything has to go in a very specific order that I hope I don't mess up. We are gonna get power through this barrel connector that will bring 24 volts to the clock. The idea is to show the time here using the right marbles, and for that we need the right marbles to get up here. But if we have all the marbles mixed up down here, we cannot choose which marbles or in which order reach the elevator, which leaves us with only one option: reject the marbles that we don't need and let go through the ones that we do. So the first thing that has to go in are the solenoids that will push the marbles out of the elevator. Hopefully is the first thing. Next are these two DC to DC converters that will take the 24 volts from the input and convert them into 12 volts and 5 volts to run everything on the clock. Next is the relay board that will actuate the solenoids, and I made this bracket for it because I wasn't sure what the whole distribution was going to be for it, and with this just doesn't matter. And now the controller board that goes on the other wall. And now I will wire these together to see if it works. First, bring the 24 volt input to both converters and all the way to the top for the stepper motor driver. I don't like wiring stuff, but if I have to do it, let's do it right. I connected one wire from all the solenoids to ground, and on the relay board I wired the common pin to 12 volts, and then connected the other cable from each solenoid to the normally open side of the relays on the relay board, and wired all the inputs from the relay board to the controller and the 5-volt power input to the DC to DC converter. And it seems to work. And to be able to reject the marbles with the solenoids, we need to position each elevator link right in front of the solenoids. And that's why I added this infrared end stop up here. The main gear has this cylinder in here with 8 slots, one for each link, that the end stop can detect. That doesn't give me the exact spot where the links are in front of the solenoids, but I can find out how many motor steps I have to move the elevator to get it right in front of the solenoids. And that will be the same amount every time. And that way we know that we can safely eject the marbles. But right now we don't know which marbles we need to eject. So for that we need some sensors. These are basically the sensors used on DIY line following robots, but I made a small change from the original clock, and these ones have the sensors mounted 90 degrees, so there is access for the bottom adjustment screw because everything is super crammed in there. I need to remove the plastic divider on the LEDs so I can get the LEDs inside the sockets that I made for them on the 3D printed bracket. And just connect all the power and ground pins together, and then add wires to all the sensor outputs. And just attach the entire thing right under the solenoids with, again, more screws. And I added this wire clamping here to keep all the wires in place. And connect the output wires to the controller. We will need to calibrate this later, but let's check with a white marble if it works. Using those sensors, I can check whether it is a black or a white marble that is on the elevator, but then we have to deal with this other issue, the gaps. The sensors can tell me if it is a white marble or not, but cannot distinguish between a black marble and a gap, because the infrared light will bounce off none of them. And that's the issue that these infrared LEDs solve. If I turn these LEDs on, the light will trigger the sensors as long as there isn't a marble blocking the light. Every time I have the marbles in front of the sensors, I do 2 readings. One with the infrared LEDs off, where I can find where the white marbles are, and another one with the infrared LEDs on, that will allow me to distinguish between black marbles and the gaps. I wanted to make the elevator gray to keep up with the theme of the original clock, but for the infrared sensors it's way easier to see the marbles against a black background, so I printed the links in 2 colors, gray in the front and black in the back, because as you can see it really makes a difference. And with that, the only thing left to install inside the tower is to properly wire the motor and to install the driver right up here. I just calibrated the sensors, and we can now do a run to see if it works just by rejecting all the black marbles or all the white marbles. And now the controller can send the right marbles down the channels, but there is no way to stop them anywhere. So let's install the 2 comms that we will control to stop the marbles on the display. I'm using 3D printed brackets to attach the servos to the back of the panels and some filament as a kind of dowel pin for the comm to rotate. And the same goes for the other gate assembly. And I wired everything together using 4 wires, 2 for power and the other 2 for the signal for each servo. And now the marbles aren't unstoppable anymore, so we can try and repeat the test and fill the display area with just black or white marbles. But before we do that, let's go to the new Prusa Core 1 that has been churning parts for this video like a champ, and grab these 2 parts in here. Just snap them together, and this just became our marble cover that will trap the runaway marbles. By the way, the gap between the snapping features in the design is 0.1 millimeters, and it worked perfectly with everything stock. What a machine! And we are ready to try to fill the display area with just black marbles. The first thing that the clock needs to do is to discard the content of every link above the sensors because it doesn't know what's there. And now I will add some more white marbles so there are enough of them to fill the display, and we'll try again. This may have seemed like a quick calibration and setup. Not so fast. I kept getting randomly shorter rows in here and there, one or two marbles missing, without any obvious explanation. I checked the sensors and even did an average reading where I was doing 10 reads for each marble, but that wasn't it. I thought that maybe the marble rejection algorithm was wrong, rewrote it 3 times, wasn't it? There were a few wires inside the tower that were too close to the elevator, were pushing out a random marble here and there. Go figure. So I zip-tied everything inside the tower and now it works. Just 3 days. 3 days. But forget the past, we are now ready to make a test and show the time. So let's do that. I will try now to run it like a regular clock, updating the time every minute. Underwhelming, I know. I've set up the code in the controller to update the time every minute, so even if it doesn't finish right in the next minute, it swaps displays and starts drawing a new minute. And as you can see, it isn't fast enough, but there is still plenty of things that we can try. First, I will modify the new minute algorithm. As it is now, when a minute expires and starts drawing a new minute, it has to empty the elevator. What I'm going to do is to make it draw a new minute immediately as it stops drawing the previous one. That requires to stop the elevator just when the last marbles from the previous digit are ejected and swap displays, but this will skip processing 8 links every minute, and that's a lot. Better, but not there yet. We are processing links at a pace of 56 links per minute, but there is a lot of dead time in that processing. Right now, every time I do an operation like reading the marble colors or ejecting the marbles, I completely stop the elevator using delays in the code. I know. But I can swap the delay cycles in the code for motor steps, so every time I have to wait for an operation to be completed, like the 200 milliseconds that the solenoids take to fully deploy, I will be spinning the motor and the elevator will never stop. Way better, it is finishing drawing almost every minute and it's processing links at a rate of 67 links per minute. I cannot even believe that you are considering building this. But there is still room for improvement, and the next one is quite easy. I'm pretty sure that you already thought of it. They're like, make the motor go faster. So it works, mission accomplished. You may have seen throughout the video that I've changed some of the parts, like this cable clamping here or the exit ramp, because I've been improving the design as I've been testing it. On the 3D model, the different screw lengths are represented by different colors. Everything to give you the sensation that this is an easy build. It's a trap.
Warning, attempt this build at your own risk. Marble clocks won't tell the right time most of the time. Marble clocks won't tell a time most of the time. Marble clocks don't even look like a clock most of the time because you will just be adjusting that little part right in there that requires disassembling it down to the last piece. Working with marbles causes losing them. Marble clock addiction is contagious. You and your loved ones may end up marbled by this project and end up in a years-long quest for the perfect marble clock. Don't attempt this project if you are affected by the clackety sound of marbles falling to the floor. Always wear anti-marble protection shoes when working with marbles. You'll step on them. Any shoes will do, to be honest. I don't even know what anti-marble protection shoes are. Shoes with holes, rugs with Ruger Jesus soles. If you work with marbles, you'll eventually have to answer the question, why on earth do you have marbles in your pocket? You're an adult more than once. The phrase, it's just one more marble clock I swear, or this has changed and it will be perfect, will lose all its meaning and nobody will believe them coming from your mouth. If you say marble over and over, the word starts losing its meaning. Marbles, 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 hippopotamus. See? See?
If after seeing what it takes to get this thing working, you still think that you have too much free time and money and want to throw it all out and want to give it a go and support my madness, there is a link to the files down below. I'll be back soon with the seconds clock. In the meantime, thanks a lot to all my Patreons and members. Thank you. And now please go and make something!